Hello friends, today we are going to discuss variables in Java. A variable is a name given to a memory location. So it's a basic unit of storage in a program. So for example, here we can see int a assigned 20. So here int is a data type, a is a variable name, and 20 is a literal or a constant which is assigned to this variable a. So when we write this statement, then JVM will allocate a memory location in the memory and assign a name to that memory location and stores this value in that memory location. Okay. So value stored in a variable can be changed during the program execution here. So if we say a assign a plus 20, then the value of a will become 40. So this 20 will be changed to 40. The value which is stored in this memory location will be changed to 40. A variable is only a name given to a memory location. All the operations done on the variable affects that memory location, the memory location where that the name is given as a that variable name. Now, when we are using any variable name, we must declare that variable before use. So when we specify int a, char a, string a, boolean a, so that it means we are declaring that variable, and we can initialize also. So when we assign some value, then we are initializing. So here we have assigned 20 value to this variable a. Basically, there are three types of variable in Java: local variable, instance variable, and static variable. Now let's see one program to understand all these different types of variables. So here, let's take a class. We can take any name for the class. I'm taking variable demo, var demo. Inside this class, we'll take one integer variable and we will assign value to this variable. Then another variable we will take as a static variable of type integer and initialize it to value 20. Then suppose in this class we have a method add. So in this method, what we are going to do, we will take another variable and initialize it to 30, suppose. And then we take one more variable to store the result. Okay. Now in D, we are adding A. We are assigning A plus B, B plus C, C, and we are printing this value. So for printing, we will write system dot out dot println and the variable which we want to print. So we want to print here D. Okay. So here in this method, we are adding variable A, which is of type integer, then B, which is of static type integer, and C, which is of type integer. Now suppose we write one more method here for multiplication. So method void and method name. Then inside this method, let's take another variable E and initialize it to 40. Then take another variable F to store the result. And inside the F, we'll multiply A into B, B into this variable E. See, variable name is case sensitive. So here, B and capital B, both are not same, both are different. Okay. So here, and let's print the value of F. I'm just copying this statement and pasting it here. And we are just printing the value of this variable F. Now we will write a main method here. After this, we'll write main method. So for main, we will write public static void main. So whenever you are writing the main method, we have to follow this syntax only. String arguments, and inside this main method we will create object of this class var demo. So var demo class, and object name is v1, assign new constructor of this class. Okay, now using this variable or this object name, we will call the methods add and multiply, v1 dot method name. Okay, and then we will save this program and execute. So here we got the output when we execute this program. Okay, so here we can see we took all three types of variable in this program. So let's start from here. So this variable which we took here is instance variable, is instance variable, and the variable which is declared with this static keyword is static variable, and the variable which are defined inside this method, these are local to these methods. Okay, so these are local variable, and the scope of this local variable is limited to this method inside this method only. So this is also local variable. Again, in this method we have taken two local variables, local variable, and this is also local variable. Okay, so this f is also local variable. So here in this program we have all three types of variable. The variable which is defined here is a instance variable. Then the variable which is defined with the static keyword is a static variable, and the variables which are defined inside any method, constructor, or a block, those variables are local to those blocks. Okay, so they are known as local variable. So here in this, when we are adding these a, b, c, so a is an instance variable, we can make use of this a here. B is a static variable, we can access B here inside this block, and C is inside this block, it is local, so we can make use of this E, C. In this method, when we are multiplying, E is local to this, so we are making use of A, which is instance variable, B, which is static variable, and E, which is local variable of this particular method. So if we want to make use of C here, we want to multiply C also, then we will get error. Okay, because C is not known here. So I'm saving this program and executing to show what type of error we will get. So here we can see we got error. Why? Because this variable is, here you can see, cannot find this symbol variable C, because this variable C is defined within this method. So this C is local to this method. So this cannot be accessed outside this method. So we cannot use C here because C is local to this particular block, and E and F, they are local to this particular block. So I hope this program is making you understand the difference between all these three variables. Now let's discuss very different variables characteristics. So this is the same program which we performed here. So here I have not included the object part, the main method which we created there. Only I have taken these two variables which we created and these two methods. So Here, first we will discuss the characteristics of the local variable. So local variable is C and D for this add method, and E and F for this multiply method. So first, declaration. So local variable can be declared inside the method, constructor or block. So these local variables can be declared inside methods, constructor or block. Next is scope. These local variables have scope inside method, constructor and block only. We cannot access or use these variables outside the block in which they are declared. Then memory allocation, when the memory is allocated to these local variables. So when that method, constructor or block gets executed, that time the very memory is allocated to those variables. And when these methods, blocks, they exits, that time these variables are destroyed. Then these variables are stored inside stack memory. Stack memory in Java is a section of memory which contains methods, local variables, and reference variables. Stack memory is always reference in last in, first out order. So local variables are created in the stack memory. Default values, these local variables have no default values. So to make use them or to use those variables, we have to initialize them before using. So we have to initialize those variables before using. Access specifiers, access specifiers like public, private, protected, these access specifiers cannot be used before local variables. Now next we will discuss the characteristics of instance variable, the same program we are using here. So these instance variables are declared inside class but outside methods, constructor and the block. So here we can see this instance variable we have declared in the class but outside these methods or constructors. Then scope of these instance variable is inside all methods, constructor or block within the class. So here in this program you can see we are able to use the variable a here within this block also, and in this block also we are making use of this a, which is instance variable. So the scope is inside all methods, constructor or block within class. And when is memory allocated to these instance variable? Instance variables are created when an object is created with the keyword new, like we created an object in that example. And that time these instance variables are also created and they are destroyed when that object is destroyed. Stored memory, these variables are stored in heap memory. Heap memory is a section of memory which contains objects and may also contain reference variables. So these instance variables are created in the heap memory. Default values, see these instance variables have default value. For example, integer has default value as a 0, boolean has a default value as a false. Then next is access specifiers. Yes, access specifiers can be used before these can be used before this instance variable. Sorry, I made a mistake here. By mistake, I have written local variable. So instance, it should be instance variable. So access specifiers can be used before instance variable. If we do not specify any access specifier, then default access specifier will be used before these instance variables. Then how to access these instance variables? These instance variables can be called directly, and in case of static method, these can be accessed using object of that class. So we can create object of this class, and using that object we can access these instance variables. Then next is our static variables. Static variables can be declared inside class using a static keyword, but outside methods, constructor or block. Then the scope is inside all methods, constructor or block, including static methods. So here we can see this B is a static variable, which is declared here as a static. This B is used inside this method and inside this multiply method. So this B can be used inside these methods and the constructor. So scope is inside all methods, constructor or blocks. Memory allocation, when the memory is allocated to those static variables, when we execute that program and dot class file is loaded. So when our program gets executed, that time memory is allocated to these static variables. Then stored memories, these static variables are stored in non-heap memory or in static memory. Again, they have default values. They can have these are similar to instance variable. For example, default value for boolean is false, default value for integer is 0. Access specifiers can be used before these local variables, sorry, before these static variables. Again, sorry, I made mistake here. I forgot to change it. So access specifier can be used before static variables. How we can access? We can access these static variables in three ways. One method is we can directly call them. Second method is we can call them using class name. So class name dot variable name. So here, if we want to access this variable b, which is static, in this class, so the class name var demo dot b. Using this way, using class name dot variable name, we can access them, or by we can use, access them using object reference, same as we refer or use them using same as we refer instance variable. So we can create an object of this class, and using that object we can refer this variable, or we can use this static variable. Now let me show you one more program to better understand the difference between this static variable and instance variable. So here I have taken a class demo, one instance variable a is equals to 10, a static variable b which is assigned, which is initialized to 20, and then we will write here main method public static void main string. We can write this program using notepad also in the same way. Here in this main method we will create object of this demo class d1, assign new demo. So here when we are creating an object, that time memory will be allocated to this instance variable, and using this object we will print the value of println, print the variable, this instance variable. So we will refer that using as a object name dot variable name. So here d1 is object name and a is instance variable name. Now we will write the same statement again to print the value of static variable. So static variable also can be referred using object. So object name dot variable name. So here d1 is object name of this class and b is a static variable name. Okay. Now we want to change the value of this a and b. So d1 dot a assign 100. Suppose we change this value, and now we will change the value of this static variable also, p2 assign 200. Okay, so here we initialized a to 10 and b to 20, and now here using the object of this class we have changed that value of a to 100 and b to 200, and again we will use this and we will print. So let's save it and execute. So here we can see the value of a and b printed as 10 and 20, and after that we change the value to 100 and 200, and again we print it, so the value is changed to 100 and 200 and it is printing. Now again suppose we create one more object of this class. Sorry, we create one more object demo d2 of the same class, and using that d2 we print the value of a and b. So here using d2 we are printing the value of a and b. So d2 dot a, d2 dot b. So here we can see what we are trying to do. Let me repeat this. We have created one object d1. Using that object we are printing the value of instance variable and static variable. Then we are changing the value of instance variable to 100 and static variable to 200, and again we are printing the value of instance variable a and value of static variable b. Then we have created one more object of this class demo d2, and using that d2 we are again printing instance variable a and static variable b, and save it and execute it. See here, this is interesting. Initially when we are printing a and b here, it is printing the initial value 10 and 20. Then we change the value to 100 and 200 and we are printing them again. So it is printing value 100 and 200. Then again we are printing the value. We created one more object and using that we are printing the value of a and b. So it is printing as a 10 and 200. See, the value of the static variable is printed as the changed value which we changed here, but the value of this instance variable is printed as an old value which we initialize to 10. What is the reason for this? This is the reason, as we discussed, memory allocation. So whenever we create a new object, a new memory gets allocated to instance variable. So whenever we create a new object, a copy of new instance variable is created. Okay, so that's why here the value which we change here is changed into a copy of the variable or the memory location which was allocated for this object. So as we discussed previously, whenever a new object is created, instance variable gets allocated a memory space. Okay, so whenever a new object is created, that time a new memory gets allocated to this instance variable. A copy of that variable is created. So here when we created a new object, that time the same a new copy which was created with the which was initialized to 10. But that is not true with the static variable, because static variables are created when the program is loaded. Only a single copy of that static variable is created, only one copy of each class variable per class is created regardless of how many objects are created from it. Only the one copy which is created at the time of program execution is shared by all the objects which are created of that particular class. Okay, so then this only one single copy of this static variable was created when the program was loaded. Then this object referred that variable, and then using that object we change the value in that single copy. Next time we created a new object, that time also only that previous copy which was created and the value was changed is referred. That's why here the value is printed as a 200. But for instance variable, the initial value to which it was initialized because is printed because a new copy was created. But for static variable, only one copy is created and that copy is shared among all objects which are created for that particular class. So that's all about variables in Java. I hope this concept is clear. Thank you so much.